All right, class. I'm excited. 8.6, solving systems by using Cramer's rule. Now, Cramer's rule, he was a little bit different. He liked to do things his own way. Came up with his own way to do these functions, solve these functions, the solving for the determinant. Okay, and what he did was he made it so that you took the solution and you plugged it through, and you were able to solve for the three x, y, and z functions in a separate manner. And this manner was called the Cramer's rule. What they did and what he did was, and we talked. Remember we talked about A11 x1. Let's just A21 x1, A22 x2. Sorry, that's x2, and this is x3. And then, all x1s, or we'll just put these as x's, and then A20, 1, 2, A 1, 2, 2, A 3, 1, A 3, 2, A 1, 3, A 2, 3, A 3, 3. And this would be our Y, and this would be our Z. Okay? Now, and they're all equal to B1, B2, B3. Okay? So what he decided is that, okay, here's the thing. You know, there's a lot of work. Those other problems you have to take a lot. Like some of you guys are like, oh, how do you know which row to cancel with which one? And is there a shortcut? He didn't like that. So what he thought, hey, here's another way we could figure this out. And so what he said is, okay, let's say I find the determinant of A. Okay, just the determinant of A, which was this information. Okay, so basically if he found the determinant of a three-sided thing, then if you found the determinant of something else and divide it, you might be able to find what x and y and z were. And so what he determined was this. He determined that if you took the determinant of A1, and I'll explain this, and the determinant of A, that would equal your x value. Your y value would equal A2 over the determinant of A, and z would A3, obviously. And I'll show you what he meant by A1, A2, A3, okay? So here's what he did. He started thinking, he said, okay, how can I make this work? How can I get this to function? Because at the end of the day, he wanted to make this as easy as possible and not have to guess at what things to eliminate. So what he determined is this, okay? What he determined was that if I made it, and he just, trial and error, just trial and error. So if he said, okay, look, if I take B and I put it in place of one of these columns, so in other words, I would have A11, A12, and B1, A21, A22, B2, A31, A32, B3. If I had that, then that would be equivalent to A1. Okay, that would be our A1. So then I would just have to find the determinant of this. So basically what he did is he just took this in and he replaced, for A1 he replaced that one, for the next one he replaced that one, and the third one he replaced that one. And so basically he just worked backwards and said, hey, let's see if this works. And what he found was that by doing that, he actually plugged in and he actually solved the problems. And so that's where he came up with his Cramer rule. So what you're doing is you're taking your B's and you're plugging it in place of one of the columns to replace here to solve. So if he wanted to find A1, he would replace the A1 column. If he wanted to find A2, he would replace the A2 column. So wherever he put the B's, that's the column he was determining, and that's how he was solving it. Okay? All right, any questions? That makes sense. So Each one of these, A1, A2, A3, represent the column that he is putting your B in, okay? So let's go ahead and try a problem and see how he does, okay? Let's see how we do as well. All right, so here we go. We'll start up here at the top. So it's negative 3x plus 7y plus 2z equals 44. 9x plus 4y plus, minus 5z equals negative 27. And then finally 2x plus 3y plus 4z equals 28. Okay, so there's our problem. So let's do our initial A is negative 3, 9, 2, 7, 4, 3, 2, 5, negative 5, and 4. So that's our initial A. So now what we have to do is, in order to solve this, I need the determinant of A, and then I need to find the determinant of all these other ones. All right, so what were the other ones? So if I wanted to find A1, or AX in this case, because we're looking for X, what you would do is you would plug in 44, negative 27, and 28, and then you're going to leave 7, 4, 3, 2, negative 5, and 4. So then a y, okay, was negative 3, 9, 2, 7, 4, 3, oops, I'm sorry, not 7, 4, 3. They're looking for 2, or y, and 2, negative 5, 4. And then, of course, a z is going to be negative 3, 9, 2, 44, 9, 27, 28, and 2, negative 5, and 4. I can't just copy, I'm sorry. 44, negative 27, 28. All right, so there's how we would find what we're looking for here. So now, well, what do? How do you find the determinant of each one of these? Okay, and that's where we go back to our last lesson to determine what that determinant is. Okay, so what would that determinant be? So how would we go about it? All right, so if I want to find the determinant of this one, okay, so if I picked, all right, down and over, right, it's going to be negative 3, negative 1, 1 plus 1, right, 4, 3, negative 5, and 4, okay, all right, plus, right? And then we're going to pick 7. So we're going to go across. We'll go across the top, right? Just for fun. 7, negative 1, 1 plus 2. Okay. And what's our going to be? 9, 2, negative 5, and 4. And the next one, plus 2, 1, negative 1 to the 1 plus 3 power, and that's going to leave me 9, 2, 4, 3. So there's our initial problem. So let's solve that. How will we solve that? Okay, so negative, so this is going to become positive, so that cancels out. So it's negative 3 times 16 minus a minus 15, right? Plus negative 7 times 36 minus a minus 10, and plus 2, because that cancels out, 27 minus 8. All right, 31 times 3 is going to give me 93 plus 46, 7 times 46, 42, so 32, 322, all right, and this is negative 2, I'm sorry, that's negative, and we're left with plus, so 19 times 2, 38, add those together and we get negative 377. So now we have our determinant for this one, okay? So what we have is x equals negative 37, and we need to find this determinant. We'll do that in a second. Y equals negative 377, and z equals negative 377. So now we have to find the determinant of this one, and then we have to determine this one, and determine this one. And once we do that, okay, once we solve that out, then we plug them over the specific information, and that's going to give us our x, y, and z. So let's say we're walking through this determinant here, okay? We'll try to keep it as small as possible. So what are we going to do? All right, very quickly and efficiently. We're clearly not going to go down. That makes no sense at all. We could do this way if we want. We could do these three if we want. So let's see. Let's do these three. They'll be the easiest, I think. So start here. 2. 1, negative 1 to the 1 to the plus 3. Right? And it's going to give me 27, negative 27, and 4. And 28 and 3. Okay? And we're talking, so what we're going to end up with is some pretty big numbers, okay? So plus the next one, negative 5. And I guess it depends on what you want to do. If you want to use the big number to multiply at the end, you can do the big outside. It doesn't matter to me. All right, then that's going to be negative 1 to the 2 plus 3. And that leaves us with negative 27, or no, 44 and 28, 7 and 3. And then lastly, plus 4, negative 1, 1 plus, or 3 plus 3. And then what's left? 44, negative 27, 7, 4. And if you do that math, I'm not going to take the time to do it all for you on the board. 754 is your number. So we plug that number in up here, 754. And when you do that, you get negative 2. Do the same thing here, and you're going to get 1508. And then here, when you do that same thing out, you're going to get 18.5. These are going to both be negative. So negative 1508, negative 1885. So that's going to give us 5 and 4. So yes, I understand lots of work, and that's how you would use the Creamer rule to solve your equation for x, y, and z. So good example of what to do and how to solve it. So